Okay, let's see. This is the video on percentages, and we'll discuss what are percentages in this video. It's video number 18, part 1 of 6. I have divided the video in 6 parts, and this is the very first part in which we would discuss what are the percentages. Let us continue here. Now, let's look at the outline for this video. First topic we will discuss is percentages. Okay. Next topic we'll consider is some of situation where percentages are used. Okay. We'll look at some of the situations where percentages might be used. Let's continue here. Then we'll look at simple interest. I call that interest shortly, but this is simple interest, then compound interest. Okay. Then we will discuss investment returns. Okay. These are all come from percentages. Okay. Then, okay. What's the percentage? It's also a fraction. Okay. Okay. How is it different from other fraction? This fraction is normalized with respect to 100, and that's kind of mathematical way to say. In simpler terms, it has implied denominator of 100. So it's a percentage has implied denominator of 100. Okay, let's continue here. It's also a ratio, and sutra here is proportionality. So percentages are ratios, and for ratios we use the sutra proportionality. And ratio may be, let's see, look at some examples here. A common fraction, which might be proper fraction, improper fraction, or mixed fraction. It might be decimal fraction, which could be exact fraction or recurring fraction. Okay, let's continue. To clarify the concept, we will consider a few examples. Let us see. So first we know that it's a ratio, a fraction or a ratio, and denominator is implied to be 100, and the ratio could be a common fraction. Let's look at example here. Example, a 5-gram gold chain has 4 grams of gold. Okay? Okay. So we are interested in how much gold is as a percentages. Okay, let's continue here. Gold weight to chain weight ratio is gold is 4 gram and chain has a 5 gram. 4 divided by 5, and that is 0.8. I multiplied by 2 and the new also divided by 2, and this would let me divide by 10, which is easier. 4 times 2 is 8, and divided by 10, move the decimal one place to the left. So 4 divided by 5 is 0.8, and you can use this trick of multiplying and dividing by 2, and that would get you denominator of 10, which is easier to divide by. Okay, ratio is 0.8, and that is normalized with respect to 1. We did not do any normalization here. It's with respect to 1, 0.8. Ratios are always with respect to 1. Okay? So now we're going to multiply and divide by 100. Okay, so if you did that, ratio is 0.8 times 100 divided by 100. Okay? So we just did a by multiplication division by 100. Okay? So that is equal to 80 divided by 100. A percentage have a implied denominator of 100. This is 100 denominator, and if I don't use that, I can place that symbol 80%. So that is 80%. 80% is percentage representation of 0.8. In an Excel spreadsheet, if you had number 0.8 and I say change format to percentages, that's what Excel would give you. Okay, Excel might give 80.00 instead. Okay, let us continue here. So what do we use percentages? Okay, some quantities are conveniently expressed as percentages instead of ratios. Some quantities have been represented in by ratios, and some others are usually represented. Why do we use percentage? In some fields, we are more comfortable with percentages. Let's give an example. A bank pays an interest of 3% per annum on a certificate of deposit. That's a time deposit. Okay, it's money given to a bank which matures in a given time. Okay, let us continue. We could also say that its interest rate of 3 cents per $1. For every dollar, its interest rate of 3 cents, 0.03. And that is now normalized with respect to 1. It's a per $1. Okay. And when we do percentage, we say per 100. Let's continue here. Note both 0.03, that number, and 3%, that number, are 3 divided by 100. See that this had an implied denominator of 100, that's 3 100. And when we convert that to a fraction, common fraction, the 0.03 becomes 3 divided by 100. The two are equivalent. Okay, one is used almost exclusively in a banking field. Okay, we feel more comfortable in banking field expressing interest in terms of the percentages. Let's continue here. However, to compute earned interest, we use 3 divided by 100. We do not usually don't use that. That's good enough. That should be usable, and we definitely don't use that. Instead, we use that form, 3 divided by 100. Okay, interest earned at 3% per annum on $1,000 for in 1 year is $30. How do that? 1,000 times 3 divided by 100, okay, is $30. There's 100 here, 2 zeros, and 2 zero cancelled out here, and that becomes $30. Okay, let's look at some more examples of percentages. Okay, in a boys team of 15, a lone girl joins. Okay, so there were a team of 15 members, and they're all boys. A girl joins. Okay, let's continue. So female players divided by team players are 1 divided by 16. We had 15 players in team. Now one more joins. I have a 16 now, and there's only one female. Okay, 1 divided by 16 is 0.0625. If you want to look at the other way, it's 1 over 4 times 1 over 4, 0.25 times 0.25, and which we know is by 1 sutra by 1 more than 1 before gives me 0.0625. On left it's 2 times 3, right here. On right it's 5 times 5, 25. And I got extra 0 here because 2 digits after the decimal and 2 digits after the decimal multiplied. I need a 4 digits after the decimal here. 0.0625. 1 over 16 is, okay, that's the ratio here of female players to the team players. Okay, now when we normalize that with respect to 100, we get 1 over 16 and 0.0625 times 100, and that then we say it's a percentage. That is equal to 6.25%. Now here is this number 0.0625 as ratio of female players to team players, and here is a in percentage the same ratio is 6.25. That number seems to be more appealing here. In this case, 6.25% of the team consists of females is more appealing than 0.0625. Part of the team is female. Let's continue. Example, if 9 more boys join the team, total number of teams members are now 25. Okay, so 16 here, 9 more joins, 25. Now if I say ratio of male players to the team players is 24 boys and total players 25, I multiply divided by 4, so that in the denominator I have a 100. Okay, so that give me 96 divided by 100. Okay, that is equal to 0.96. Then we multiply by 100, they give me 96%. To convert a ratio 0.96 to a percentage, we move the decimal place 2 places to the right. Okay. Okay. To convert a ratio of 0.96 to percentages, we move the decimal places 2 places to the right. We did same thing here, 0.0625 right here. We decimal place was here and we move the 2 places to the right, 6.25%. So this is 6.25%. So similarly, to convert a percentage to a ratio, we will move decimal place 2 places to the right. 6.25% become 0.0625. It's just a common practice to use a zero. If a whole part is zero and the decimal fraction consists is only fractions only, uh, fraction of a whole number, then zero, it's usually we write a 0 point instead just a point. Okay, 6.25%. Here, same thing here. It's answer is 0.296. We usually write 0.96, and now we move the decimal place to the right, become 96%. We move decimal place points to the left, become 0.96. Let's continue here. To convert a ratio to percentage, move decimal place 2 places to the right. Decimal point 2 places to the right. Let us continue. Let's look at references here. First reference is Vedic Math Teacher's Manual, Volume 1. This is Elementary Teacher's Volume, and it's by Ken Williams, and you can find it at vedicmaths.org. PDF form is available for free, and print form you can purchase. Let's continue here. Second reference listed is the common reference, that's the primary reference, Vedic Mathematics by Bharti Krishna Tirtha ji, and that is the primary reference on the Vedic math. Tirtha ji is a founder of the Vedic math. Let us continue. Now here is Discovery Vedic Math by Ken Williams. It's a most complete, authoritative, and consistent notations, and this book is organized by sutras. Let's continue here. Vedic Math for Schools in 3 volumes by James T. Glover. Mr. Glover used these books in his school. They're very easy to read, very complete, not as complete as Williams' book is, and contains significant geometry which I have not covered at all. Let's continue here. And Figuring by Shakuntala Devi. I used some of the exercises from this Glover's book, and I used some of the examples from this book Figuring. Let us continue here.